let's look at B. So we just talked about how when we're writing these, we must write the probability statements. So B says, what is the probability that a student who got less than 6 hours of sleep failed the exam? Is this a conditional probability?
Yes.
Yes. What is the condition?
Less than 6 hours of sleep.
Okay, so this time it's less than 6 hours of sleep. That goes after our bar. So sleep. Less than 6.
And fail.
Okay? And fail. Okay, so we want fail.
So 10 out of 22.
Alright, so this time we are not looking at the failed column. We are looking at our condition column, which is sleep. So this time we're looking here.
Oh, that was bad.
Alright, so this would be, how many failed?
10.
10 out of how many are there?
22.
22. And so what does this give us
I don't know.
as a percent? 45? Okay, so once again, this really bothers me because generally we would not write probability as a percent. We would write it as a reduced fraction or a decimal. But the directions ask for a percent, so we're following the directions.
When? No. For your
On my test, it won't ask for a percent.
It will ask for a decimal.
Yeah. Alright, C. To the nearest percent, what is the probability that a student got less than 6 hours of sleep and failed the exam?
Not a condition.
Is there, no, there's not a condition. So this is probability, sleep,
And
less than 6, and fail. Okay? So what we're looking at this time is inside, the intersection. The intersection are these inside. Sleep less than 6 and failed would be 10 out of, what's the total this time? 120. Awesome. Okay, so this gives us 8%.
yes.
Okay, so if this was my test, you'd probably leave it 112.
Oh, you still want to use fractions?
I'm good with a reduced fraction or the decimal.
That's what
I have both on my answer key already, so I'm good.
So,
Yes, sir.
In the probability statement, could we write the intersection symbol instead of
Oh, I like it. Okay, which way is the intersection?
down.
up?
Down. Come on, guys. It's not union. It's interesting.
Okay. Very good. Okay, so number 2, a botanist studied the effect of a new fertilizer by choosing 100 orchids and giving 70% of the plants the fertilizer. Of the plants that got the fertilizer, 40% produced flowers within a month. Of the plants that did not receive fertilizer, 10% produced flowers within a month. Find each probability to the nearest percent, and it says hit.
No.
Construct a two-way table. Hit. Alright, so let's do it. Let's construct a two-way table.
Do you want us to draw that on ice?
There's a little space up here. You can draw it.
Oh, okay. You're gonna do 1, 2, 3, 4. Because this is math class, it's not Spanish class.
You have to practice.
I wish we had those.
They call it a ruler.
Okay, so we have 2 things going on here. What are they?
Flowers I got.
We got flowers and fertilizer. So flowers, and then our other one would be no flowers, or not flowers,
Can we take?
and then fertilizer and not fertilizer.
I really broke. If you said it, yeah. Why? Just write yours is gonna be like that. And mine is gonna
Okay, the nice thing is they gave us 100. So if we could put them in decimals, or we could just leave them as they are and know that that's the decimal because it's 100. All right, so let's read. 70% of these plants were given fertilizer. This statement does not talk about flowering at all. So let's start with it. 70% received fertilizer. So what's 70% of 100? 70. And that leaves 30. Okay, so do you see where to start? The one that just involves one of our two parameters. Alright. Of the plants that got fertilizer, 40% produce flowers. So what's 4 times 7?
28.
Yes, it is. Okay, so if 28 produced flowers, how many did not? 42. Okay? Of the plants that did not get fertilizer, 10% produced flowers. So what's 10% of 30? 3. So what does that leave here? 27. Okay, so this is 31. And this is 69.
Don't equal. Okay. Not equal that.
Okay, so A, find the probability that a plant produced flowers got the fertilizer. Is there a condition?
No, there's not.
Yes, what is the condition? That they produce flowers.
Well, I did that.
Okay? And we want to know yes.
When you're reading a conditional statement or probability, will the one that's given always be first?
Not necessarily. I can word it both ways.
Okay.
And I think I did on your review
Okay.
so that you could see it.
Okay.
If I didn't, I will make sure I do it in a warm-up. Okay. All right, so in this case, that looks like farts. Is that what y'all were laughing about? I'm like, that's so bad. Okay, fertilizer. I'm glad we're recording. All right. So fertilizers over flowers. How many? Our flower total is 31.
31, okay, yeah.
And how many of them got fertilizer? 28. So that's, I totally recovered. We bounced back.
Oh, I broke my pants on last.
All right, B. Find the probability that a plant that got fertilizer produced flowers. Is there a condition?
Yes.
What's the condition this time?
They got fertilizer.
Yes. All right. So now we're looking differently. We're looking here.
Okay. So it'd be flower, it'd be 28 out of
To be 70.
Yeah, 28 out of 70. Which is, hold on,
That's
0.4.
0.4.
0.4. I beat you to it.
Are receiving fertilizer and flowers independent events?
Let me think about that.
What test of independence could you try and see?
First one.
Yeah, I think it's.
You want to do the first one? All right. Anybody want to do the second one?
I want to do the first.
All right, do one. Pick one. Do it.
It's a terrible room. I'm gonna do it though. If I need it.
Because it's so much fun.
I love math. I really do like math. I get better at it. You don't like math?
Okay, so fertilizer and flour would be 28 out of 100. Is that equal to fertilizer? 70 out of 100 times flowers. 31 out of 100.
Where am I looking at?
That's the first test of independence, right? That the intersection is equal to the product of the two individual probabilities?
I'm looking.
If and only if?
Oh, there.
The probability of A and B is equal to the probability of A times the probability of
Oh,
B
they're
if we have
equal.
independent events.
So if they're equal, then it means they're independent?
Yes.
If they're equal, we have proven independence.
Then they're
If they're not equal, we have not proven independence. Could be, but we didn't prove it.
If I drop this highlighter one more time.
Okay, so 0.7 times 0.31 is 0.217. Are they equal?
No.
No.
They are unequal.
Alright, so have we proven independence this way?
Yes.
No.
No.
Okay. So another one would be probability of A given B? Okay, so fertilizer,
Actually,
28, no, fertilizer is 70 out of 100, and fertilizer given flour is
28.
out of 31. So this is 0.7. Does that equal 0.9?
No.
No. So, we cannot prove independence.
so.
We cannot prove that they're independent. And they probably are dependent, because generally fertilizing something does cause it to grow and to flower, right?
Right.
So, yeah.
Will it have to work for both tests, or is there a case where it'll work for one test and not work for another?
I do not believe that is true.
Okay.
I will verify with Miss Morgan, because she's the one that is the probability stat queen.
Because I just didn't know, like, on a test, if we'll have to do, like, both one test and one.
Nope, if it fails one, I am almost 100% sure it will always fail the other. But I will double check with her on that, and I will let you know. Yes, Joseph?
I'm not really sure if it's important to the problem, but if you can't prove that it's independent, do you just assume that it's dependent and vice versa?
That if you can't prove that it's independent, it doesn't necessarily mean it is dependent, but it can be dependent.
Usually if you can't prove it, that means.
I know.
That's what we
All right.
One
This
more.
one. Okay, so last period I did the tree diagram. I'll show you.
No, please.
And I didn't like it. I struggle with tree diagrams.
Oh my lord.
Okay? But they're good. They are good. But it's harder for me to see. I can see it so clearly when it's in the two-way table. But I needed the tree diagram information to complete my two-way table, didn't I?
We do.
Maybe.
I think you did.
Maybe I could work my way around and have done it without that. Okay? But on this one, it says, at a school fair, a box contains 24 yellow balls and 76 red balls. 1/4 of the balls of each color are labeled win a prize. Okay? So, two sentences there. One just deals with color. The other sentence deals with color and winning. What's my first branch? Color. So that's what I did. My first branch was yellow, red. And then I did win, not win, which we can say lose, right? Or win, not win. And found those probabilities, filled in my chart. Now, find the probability that a ball labeled win a prize is yellow. Win a prize tells me I'm just working with the win column, right? That is labeled yellow would be 0.06 out of the 0.25. Dividing by 0.25 is like dividing by a fourth, right? Which is like multiplying by 4. Dividing by a fraction is the same as multiplying by the reciprocal.
Right.
And 0.06 times 4 is 0.24.
I do.
See how you can do that problem without a calculator? Yeah.
So you're gonna make us not have a calculator?
Sometimes. But I would like your brain to be nice and strong.
Thanks for it.
Okay. All right, find the probability that a ball labeled win a prize is red. Now, I don't have to do any mathematical calculations because that's the complement of this, right? So if this is 0.24, this has got to be 0.76. All right, find the probability that a ball is labeled win a prize and is red. Okay, these two were conditions. This one is not. This is the intersection. Do you see the difference in the wording there? So here we're working inside the table. Inside the table is the intersection. Red and win. 0.19.
If it has and, then it's in the intersection, but if there's no and.
A lot of times that and who, those will indicate a condition or a given. Sometimes it's the word given. It's hard to miss it when it's the word given.
So if and is in, it does not.
Here we don't have, we have that a ball. It's not that a color or it's that a ball. So this is taking us inside here because we're looking at all the balls. Okay, now this is that a yellow ball. So that's a condition, right? So this would be 0.06 divided by 0.24. 0.06 divided by 0.24. We could just reduce it. 6 over 24 reduces to 1/4. 0.25. Okay. Your homework is out of the textbook. We talked about how to get to the textbook online. We talked about if that fails to work for you, where can you find your homework? And Willoughby World on the calendar.
Are you serious? That's my other friends award?
Yeah.